This is 5.7, solving quadratic inequalities. Let's go ahead and write the topic down, and then I'll kind of read through these 3 steps. Don't write the steps down. What we're going to do today is we are going to graph first quadratic functions. How we learned how to do this was in sections 5.1, 5.2, and 5.3. And then the new piece is where we test a point inside the parabola and test a point outside the parabola and see which one is true in the inequality. And then the last step is just to shade the region that is true. So go ahead and write this example down. We're going to be doing 2 examples in this lesson. So here's the first example. We want to graph the solution to this quadratic inequality. So we have y is greater than or equal to the quantity of x minus 2 all squared plus 1. So step 1 is think of this as a quadratic equation. And we want to identify first the critical point. The critical point is the vertex of the function. I'll give you some time to write that down. So remember, in vertex form, what's inside the parentheses tells me my transformation right or left, where I have to think opposite. So I'm going to move this parabola from its parent function 2 units to the right. And then what's outside the function, the plus 1, moves my graph up 1 unit from its parent function. So what the vertex is 2, 1. So I'm just going to go ahead and write that as an ordered pair, 2, 1. That is called my critical point or vertex. Now I'm going to go over and graph a coordinate plane. So I just want you to listen and watch how I graph the parent function. Don't need to graph this on your paper. So I'll just quickly graph the parent function y equals x squared. If you remember, it starts at the origin, and then it's 1, 1, and negative 1, 1. Then the next set of ordered pairs is 2, 4, and then negative 2, 4. What we're going to do is we're going to pick up this parent function and move it 2 units to the right, and then up 1. I'm just going to erase this now. And my parent function was originally at 0, 0. It's now going to be our new graph. It's going to be over 2, up 1. There's my vertex. And I'll graph now my points. We're going to move right 1 and up 1, and then left 1 and up 1. So there's the start of my curve. So that ordered pair is 3, 2, and 1, 2. I'll just put them over here also. So 3, 2, and 1, 2. Now I'll move 1 more unit to the right and left. So I'm at 4 and 0. Now remember, from the parent function, the next jump in height is 4 units up from its vertex. So I'll have a point here and a point there. And that point then is 4, 5, and 0, 5. What I've done is I've graphed the quadratic equation of y equals x minus 2 all squared plus 1. But the question is asking us to graph the solution. So we want to move on to step 2, where we're going to test a point inside the parabola and test a point outside the parabola. So go ahead and write down step 2. Test a point inside the parabola and outside the parabola. So I've already chosen 2 points. A green point of 0, 0, which is outside the U, and the point 3, 4, which is inside the U. So go ahead and write that down, step 2. So where this 0, 0 is right here. And we want to see if this region outside of the parabola is true for inequality. So we're going to substitute 0 and 0 into this inequality. So the first value is your x, the second value is your y. So we're going to go ahead and substitute those in. So 0 is y, 0 is x, and now we reduce this inequality down to see if it's true or false. So reduce inside of the parentheses to -2 squared, and then -2 times -2 is 4, and then add them. And now let's read that. Is it true that 0 is greater than or equal to 5? No, that's false. So we know that any of the ordered pairs outside of the U are not solutions to this inequality. Now let's go and check and verify that 0.34, which is now inside of the parabola, over 3 up 4, which is right about here. That means any point inside of the parabola should be true if we substitute it into the inequality. So this is my x value, that is my y value. Now let's substitute in. So I get 4 is my y value, 3 is my x value, and now we reduce that inequality down to see if it's true or false. So 3 minus 2 is 1. 1 squared is 1. 1 plus 1 is 2. Now let's read the inequality. 4 is greater than or equal to 2. True. So the region that we're going to shade is the region that is true. So that means any ordered pairs inside of the parabola will be solutions to our quadratic inequality. So then we would shade this region right in here. This is part 1 finished. We have a part 2, which is the second problem of our lesson. I'll stop the recording.